Hello, welcome to the first video of a series of tutorials where we are going to show you some basic tools that we want you to learn during this course. This is not a full blown lecture, but mostly I will be showing you some techniques and I will be trying to code along you a lot. On this first tutorial, we want to show you how to work with Linux, but it's going to be extremely basic, so it's not going to cover the full story of how to work with the GNU Linux system, but at least I'm going to try to show you the bare minimum tools you should have in order to succeed with this course. Let's get started. So why we're going to use GNU Linux? So Linux is a super popular choice for development nowadays. In our particular case, where we target computer vision applications and mobile robots, it's really important to understand that most of embedded systems nowadays will be running some sort of variation of the Linux operating system. So therefore, it's much easier to develop with the same platform that's going to be the target platform. Although there are still some small devices where you don't have any kind of operating system, that this we call bare metal, we're not going to go into any details on how to work with those embedded systems on this course, but rather targeting Linux or embedded Linux. Linux is a free Unix-like operating system, so Linux is basically inspired in Unix, that is the operating system that was created along C on the 70s, so many years ago. The kernel of the operating system was implemented by Linus Torvalds, and therefore the name comes from there, and Linus is still developing the Linux kernel nowadays. So this is something really particular from this area of the technology that is being developed with people who are still alive and working along us. So nowadays it's extremely popular, and this means that it's basically everywhere. So it's on Chrome OS, it's on some sort of notebooks, on any kind of mobile robots. It's very likely that some sort of variation of Linux is running. Android is based on Linux, so most of the cell phones out there are also running some sort of variation of Linux, and it's basically ubiquitous. It's something that now it's everywhere. So even if you grab some measurement instrument like an oscilloscope, it's very likely that it's going to be running a Linux operating system inside the instrument. So Linux nowadays became really popular, and this is also good because it allows us to work with tools that everyone is also using. So there are many distributions available. The fact that the operating system is free and open source allow you to change it the way you like it, and therefore infinite amount of distributions came into place in the last 15 years. So our recommendation is to just stick to Ubuntu. That is probably the most popular distribution out there. And if you struggle, if you have some sort of issues, it's much more likely to find an answer on the internet than just trying to look it through some documentation from some really particular distribution. Even though when I don't use plain Ubuntu, my operating system is basically based on top of Ubuntu 20.04. So whatever I do on my computer and whatever you see, you can also do it on your computer if you have installed Ubuntu 20.04. So the takeaway message of working with Linux I want you to take home is basically everything in Linux, it's a file. No matter if it's like a real file, like a text file, or if we are speaking about a camera, like the camera I'm using right now on my Linux system, or whatever kind of device you have connected to your computer, everything in Linux, it's going to be a file. So this is super important, and therefore you should somehow understand how the Linux directory structure was designed. So this is something that came from Unix on the 70s and has been the directory structure, the tree structure for all the Unix or Linux based system since 50 years, because it's rather simple. So everything will start with root. So I will do some highlighting now. So everything starts here with the root directory, that is always the slash directory, and from there all the other directories will be a child of this root. So the root is going to be the starting point of the files of your operating system, and everything is inside this root. That's why the name root. And it's important to notice that inside this root or inside this file system, there are not any strange volume letters like C, D, E, F, or whatever. Of course, if you have different disks, you can mount it into different points on your system, but that's rather another story. So most of the cases you will be wanting to pay attention to your user home space. This basically is whatever comes inside /home/ your username, and that's where you have permissions typically to write files, store data, and do your work here. So the other directories you will have, for example, on this local directory, you will have the libraries that you installed locally. So if you install OpenCV later in this course, the OpenCV library is going to be located here. The bin directory is going to have the binaries that you will be using, the libraries, and so on. And everything starts with root, and then from there you go down, and then you, for example, if you want to reach this local directory, then let me clean. So the path you should follow is the following. So you start from the root directory, and then you go to the user directory, and then you go to the local directory, and that's how you reach the path. So it's always going inside the folders, and it's extremely easy once you get used to it. So make sure you remember the takeaway message is everything in Linux is a file. No matter what we are talking about, in Linux it's going to be a file. Then we move forward. So this is like a summary of how to work with these files and folders. So in Linux, everything that ends with the backslash is going to be a folder. So if I find my highlight, so this is the backslash I'm talking about. So if the path we are discussing ends with the backslash like this means that we are talking about a folder or a directory, depending how you want to call it. And then everything else is going to be a file. So if you pay attention here, so at the end of the path, there is no backslash, meaning that basically this is going to be a regular file. And then also we have something we call absolute path. That is basically when you provide the full path from the root directory of your system towards the end of the file you're looking for. So in this case, if we want to, for example, if you want to access this folder, we say this is an absolute path because it starts from the root directory. So if you check, it's starting from here, from the root directory, meaning that we're going to provide the full path to the file. But let's say we are working in another directory, and then we go from this directory towards another file. Therefore, we can provide something that is called a relative path. That is going to be this example down here. So in this case, because we are not providing the backslash at the beginning, the terminal is going to be prepending the current working directory, so you can reach the file with a relative form. And then the path are case sensitive, so make sure you remember this fact. So the file name, these two file names are completely different over here, and then the extension is part of the name. So the extension doesn't mean anything particular or anything rather special, but it's basically part of the file name. So filename.cpp is only different from filename.png, not because there are different files, but basically because the name is going to be different. So to open a terminal in most of Ubuntu-based distribution, you just press Ctrl-Alt-T, or just go and look to the terminal program, and then therefore you can start working with the terminal right away. I will show you a simplified version of the terminal now that I have in order to make it fit with the slides. Most of the tasks you usually do from the GUI, that is basically the graphical interface, you can do it from the terminal. So let's say you want to rename a file, you can do it with the GUI, with the File Explorer, or you can also do it with the terminal, and it's rather much more convenient because let's say you, for some reason, you need to rename 50,000 files. I guarantee you that if you find a way of how to do this with the terminal, you can automate this process and not go and change 50,000 files by hand. So how to navigate this tree structure from the terminal. Basically, there are three main commands, that is print working directory, change directory, and list directory, and we're going to show you right away. Okay, so let's fire up a terminal. So in this case, this is a terminal that is basically bit modified, so it fits the slides, and we can see the slides while we code along. So basically, if I run the print working directory, I'm going to see in this case that I'm at /home Vizzo, that is basically my user folder, and then I can, for example, ls to check what is inside here, and then let's say I want to go to the dev folder, and I just will do cd and then dev, and this dev is basically a relative path, so I could be doing this to go there, or I can basically go to my home directory again, and I can do the full path, the absolute path, that is going to be home Vizzo and then dev. That is basically the same place. So if you see, my shell here is highlighting where is this located, and in both cases we reach the same place. There's basically 4 special kind of characters. The first one is the root directory, the slash. So if I go to just the root, I'm going to be on the first point of my operating system, on the file system. And then if I, for example, I go to the tilde, this tilde is basically an alias for my home directory. So if I do print working directory now, I'm basically on my home directory. And then the last two is basically the current folder and the parent folder. So if I go to dev, if I do ls, for example, and I provide an argument that is dot, and it's going to be the same as ls, because I'm basically listing this current directory. And if I do ls dot dot, basically going up, and it's going to be listing my home directory. So this is basically super simple. If you don't really understand, the only way to get through it is open your terminal, stop the video, pause the video, and start typing this command and play around. So it's free, it's safe, and you don't really lose anything with trying. So if you are already a bit lost with your terminal, just go to the terminal and start using it. Let's go back to the slides then. The structure of the Linux command is always the same. And I want to tell you right now that the concept or the idea of command is rather something complicated, because if you remember our first takeaway message, everything in Linux, it's a file. What is the meaning of this? There is no such thing as a command. It's basically a file that is going to be located somewhere in your system, and when you use this file, when you execute this file, because it's going to be, you are not going to provide the full path, it's going to have the feeling of a command, and that's why we call it a command. So ls, if we go back to ls here, so let me clear the screen, and let me go to my home directory. This ls here is basically a command, or we call it a terminal command, but it's nothing but a file. So if I know where is this file located, so if you do user bin ls, now you're providing the full path to the command, and if I execute this, it's going to give me, user bin ls is going to give me the same answer of the ls command. And why is this? Because I know where is the file located, I'm just executing. So a command is rather a file that is somewhere on the system. Therefore, it's important to notice that here we have this path that is nothing but a variable on your local system that will tell you where you should be looking for commands. So whenever you fire up a command on the terminal, like ls or print working directory, the shell is going to go to this path variable and look through all the directories that are listed there to find for this ls. So, So if we go here, if I basically show you what I do have on my path, I basically have all these directories here on the left. And basically when I fire the ls command, first it's going to be looking on this directory to find it, and then into this one, and then into this one, and so on. And at some point it's going to reach this user user local bin, that is the one we were doing with ls, and then it's going to find the file and it's going to execute it from there. So that's basically the idea of a command. Each command, that is basically each program, will always or most likely have options and parameters. So if, for example, you do ls and then you say help, this is going to give you the help of the command. Let me make the terminal bigger. And then these are all the arguments you could use with ls. And sometimes it's too verbose, all the description of the command, and therefore you can check for the manual. And then the parameters, basically it's going to be program specific parameters for the particular command you're trying to use. Like, for example, the input files and stuff like this. If you got lost with any command, there is the manual that is always the user manual for each command, or most of the commands out there or programs will have the -h or help in order to know what's going on. So, for example, let me make the terminal bigger again, and then if I do man ls, basically this is going to show you all the options for the ls command, and you can navigate through it in order to see what's the thing you're missing or the particular task you need. So then let's continue, because this is rather simple. Then this is just a trick, a hint. Whenever you are working with the terminal, make sure you use the tab. So when you tab, you basically you can autocomplete what you're doing. So if I do cd and then I do dev and I tab, I'm going to get some prompt from the terminal, and let's say I want to go to dev, and now I'm reaching the point I was looking for. So make sure you tab always, because it's much easier for you to navigate through the terminal. So in order to create files and folders, these are the 4 most common commands. If you are looking this video, I highly recommend you to pause the video right now and go to your terminal and start working around with these commands. I'm going to skip through it because it's extremely simple, and I know you could do it by yourself. The other stuff you could probably do after like working with creating some files and copying files from some place to another is to use some special characters on the terminal, like placeholders. So I'm going to show you the first one, and then as a homework you also have an example slide coming next, and you should also play around a bit with all these other files. So let's say I'm going to go to my root directory, and there's this temp directory was here, and here I'm going to create a directory that you just learned by yourself on the previous slide, and that is going to be placeholders. Now I'm going to cd into this directory, and if I list here, of course it's completely empty. So let's say I want to create 10 files, or let's make it even easier, let's create just 3 files. One way of creating files, like empty files with nothing, is using the touch command. So I can do file 1, file 2, and file 3. And now when I ILS, I have these 3 files. So one option, let's say that you for some reason want to delete these files, and then you could do remove file 1 and then file 2 and so on. But what happens when you have 50,000 files? Then it's going to be a bit messy, and therefore you could use the star placeholder that is going to give you basically anything. It's like a globe. So if I do rm, that stands for remove, and I specify the globe operator, when I do this, it's going to remove all the files, and actually my shell is telling me you are just about to delete 3 files. I would say yes, and then when you ls, it's basically gone. So now I will invite you to stop the video again, and then go to your terminal, create the files you see here. So first create these files, these 9 files, and how to create it. You can use the touch command and specify the extension. There's no need to be a real PDF there, just a file, and then try to play around with this or with some variation of the commands I'm showing to you on this slide. And therefore we go to one of the most important parts of this lecture here. So the standard input and output channel are basically the same on any Unix-based system. So you will always have or most likely you will have a standard input channel that is basically assigned to the channel 0, and then you have two output channels, that one is going to be for the standard output and the other one is going to be for the standard error. Traditionally, these channels are going to be one for the standard output and two for the standard error. So you already saw some standard output and standard error manipulation on the first lecture of this course. So basically I have one example for you here. So whenever you run any program that is going to be a file on the system, because you're using Linux, this is what is going on under the hood. So the program will be always reading from the standard input that on the desktop computer is going to be the keyboard of your computer, and then it's going to be outputting to the monitor that is assigned to the standard output, and the standard output and the standard error are assigned to the monitor on desktop computer. So every time you run a program, this is what's going on under the hood, basically. So I have one example program, so we can work a bit with this example, and I can show you some redirections of these channels on Unix systems. So if I go to my directory, my home directory, so let me show you where I'm located. I have one example here. So I have a precompiled binary here that is going to show some operations with the channels. So after we finish the explanation, the idea is that you stop the video again, and then as I told you on the first lecture, the idea of this course is you get hands on the keyboard and then you work a lot, otherwise it's very hard to learn. So once we finish with this explanation, stop the video, and the exercise is you should code the C++ program that exactly represents the behavior I'm going to show you. So I'm not going to show you the source code, but rather how the program behaves, and then you need to do some sort of reverse engineering and make the source code by yourself. So on the video you will have the example on how the program should behave. So let me clear the screen. Sorry. And let me execute this example. So here on the standard output, we have a message that says, please input a number bigger than 100. Let's say for some reason we didn't read the message and then we put 5. And we will have an error message saying, on the standard error channel, the number is not bigger than 100 and it's basically 5. Then we try it again. And then now again we're reading, so we are inputting data from the standard input that on my laptop is assigned to the keyboard. And let's put 500 now, and then on the standard output I have one confirmation message that is basically 500. So be aware that this string over here and this string over here is not normally something I put on my program to make it more obvious to you where is this going to the standard output or to the standard error. Let's go to the next example. So let's say that for some reason we want to show the user only the errors, but the standard output, we want to put it into a file. How we do it? So there's a simple syntax on any Unix-based system that is basically this angular bracket syntax. So basically one that is the standard output channel, and that's why the one is there. We say, please put this, and it's like, you just put it here into one file. This file could be whatever file you want. So basically now if I do the example and I say redirect one, that is the standard output, to a file that is called, I don't know, standard output.txt. Now the message of the standard output, please enter a number, is not being shown because it's on the file actually. So now I will show you the file, how it looks when it ends, and you will see the message. But we remember the behavior, and then let's put a 5 again, and then now we see the error. Why we see the error? Because still, so the error message is going to be printed to the standard error, and if you see, this is still going through the monitor over here. That's why you get to see the error. Of course, if you now ls here, you will see this file you just created, and then if you cut, that is to see what is inside the file, this file, you will see the message you were expecting at the beginning. So of course the same you could do with the standard error. So you can just show the standard output, and then redirect the standard error. How? Using a 2, because the channel assigned for the standard error is 2. So basically, if we now do the same Linux example, but then 2 is going to be an like error txt, so to this file. Now we see the standard output message on the monitor because we didn't redirect it, and then when we put 5, the error message is not being shown because now it's on the file. Ls, you see the error file. If we see what's in here, the standard error message is going to be prompted there. And of course, you could do some other stuff like, okay, I want to have one file for the error, one file for the standard output channels. And then if you run this, so basically one is going to be for the standard output, and then 2 is going to be redirected to the error file. Now you don't see anything because everything is going to be redirected to the file. So if I put 5 here, all the messages are being lost because both messages are on each independent file. So again, if you for some reason got lost, you just stop the video, open your terminal, start working around, open the files. If you don't want to check the files from the terminal, open the files with the text editor. I don't really care. The only thing is you should really get your hands on so you can develop this experience and learn while you type. And this is the last example we're going to see because the syntax is a bit more complicated, but it's basically the same principle. So what we are doing here is basically we are first redirecting the standard output channel, so to one file that is out.txt. But then we say, you know what? Let's also redirect the standard error that is 2 to whatever is pointing to 1. And then in this case, it's going to be splitted to the out.txt file, meaning that we are going to put both on the same file. So let me remove these files just to clean up my workspace. I only have my example. And then if I do this, like out.txt, and then the standard error that is 2 is going to be redirected to whatever is on 1. It's asking me for the number. I will put 5 again, and then if we check this file, we have both the standard output and the error on the same file. Again, now you should stop the video or pause the video and then try to write a C++ program that behaves exactly like this Linux example. These messages are optional, so the standard output or error. But what you should do is go through the slides that is going to be on the link down on the description, and then make sure that all the examples I'm showing you here, you get the same output. Check the files so you know that your program is properly working as I am asking you to make it work. And then we move forward. So these are a rather short list of the commands you should always have on your belt, on your tool belt. So I'm not going to show you all the commands, of course, but it's basically a summary of what you should have in mind always in order to work fast with the terminal to allow you to do the task you will need to do for programming in C++ and working with Linux in general. The other important thing is how to change commands. So if you remember on the lecture 0 when we saw the hello world, so when you see each program finishes its execution, it's going to return a code to the shell basically. And then if this code is different than 0, then it's going to be an error, and if it's 0, it's going to be no error. So let me show you basically one example over here. So let me clean again here this workspace, and then let's try to cut to see what is in like file.txt. But if you check here on ls, this file doesn't exist. So now I'm going to get an error on the standard error channel, but actually if you check the return code from this program with this command, you will see that it's 1, meaning that there was an error. So if I want to change the command with this operator that is a semicolon, this is going to fail. So this semicolon operator basically means run the command 1, run the command 2, run the command 3. Sorry, it's not going to fail. it's going to run it no matter what. So if I do, for example, cat file txt and then cat file2 txt, both commands are going to run and both are going to fail. The other option is going to use the double ampersand, that is basically going to say, tell the terminal, first run this command and only if it doesn't fail, so if there's a return code that is exactly 0, then move to the following command. So if I run now this, so in the previous example we were running both commands no matter what, and therefore we got the 2 error messages. And in this case, because I'm telling you just move forward if you don't fail, we should see the error message for this command, and then this one should not be prompted. And as expected, so we did the first command, it failed, and then we abort the execution of the rest of the commands. Then something that is extremely important is piping. So basically when you pipe something on Linux, you basically use the vertical bar operator, and then when you pipe, you basically put whatever is on the standard output of the first command to the standard input of the command 2. So if we go back to this slide, so when you're running a program by itself, so the keyword is going to be injecting data into the standard input over here, but when you're piping commands, you basically have another program here on your chain that is going to, so let me try to draw it. So we will probably have a so this is going to be another program. This is not going to be part of the story anymore, so just wipe it out. And then basically the standard output of the first program is going to be feeding the standard input of the following program. And that's basically the main idea behind pipes on Linux. So basically, and so on. So if you have a third command, so the standard output of this command is going to be being injected to the standard input of the third command. So how you can use pipe to do really cool stuff. For example, here, let's say you have multiple files. So let's create files again. And then let's say you're looking for file 3. So when you see ls, that is basically listing the directory you're working right now, it's printing this to the standard output because you see it on the monitor on the terminal. And therefore, maybe you can use grep, that is a command that when you provide something to the standard input of this command, it's going to search through this. So basically now with the pipe, so the standard output of ls is going to be fed to the standard input of grep. And here I can provide some query, like for example, file 3. And this is the file I'm looking. And if you see, I have the output is now being shown in the standard output channel as a terminal. And I know that on this directory, I have this file 3 I was looking for. There's a cool video on how to use Linux and command line pipes and redirection. So it's basically what we just saw. So in case you want another perspective or someone else explaining this to you because you think it turned to be more complicated, I highly recommend you to watch this video. I think it's a 10 minutes video, so it should be enough for you to get a grasp of what you need to work with Linux. Then last but not least, so if you want to run some command and then for some reason, let's say you run into an infinite loop, there's many ways of killing it. The ones I would probably recommend you because are the most easy ones are Ctrl+C. So basically Ctrl+C stands for canceling this command. So if you're running on the shell, just press Ctrl+C and then you will cancel. Or you can use htop or top. There are applications to watch whatever is on your system and look through the commands and then try to kill it with the K operator button, basically on your keyboard. So this is rather like a trick how to navigate with the commands on your Linux computer. So if you see, if I go up, I can see all the commands I just ran. Of course, if I also do history, that is a command, I can check all the commands I just ran, and then I can also rep using the pipes for example, cat, and I can see all the commands that I did with cat on my story. So again, stop the video, try to run all these examples here so you get used to how to work with the terminal. Installing software in Linux is extremely easy. So typically just sudo apt install the program you want. And if not, you should Google, or maybe if you have the source code available, it's typically easy, but it's traditionally much more easy to install it on Linux if it's available on the main repositories of your distribution than installing software on Windows. So let's say you want to run htop. So htop is this application to watch all the process on your computer, like this one. And then if you don't have it, the only thing you need to do is sudo apt install htop, and then it's going to ask your password, and then this is going to install the htop binary on your system, which is extremely easy and convenient. So, and to finish this video, I would recommend a Bash tutorial. So in case you're really new to Linux and scripting, this is probably a good starting point along with this video. So yeah, I highly recommend you to at least watch it. And again, while you watch it, stop the video, run the commands on your terminal, and get used to it. That's basically it from my side. I highly appreciate your attention. And if you have any questions, just ask me or Rodrigo, and we'll be happy to answer. Thank you.